Hi, in this Unity tutorial, I'll be showing you how to implement a simple homing missile. Let's first explain the missile behavior. It consists of two stages. In the first stage, the missile launches straight up into the air for a certain period of time. Once that time expires, the missile switches to stage 2, in which it becomes armed, causing it to explode on any collision. It also self-destructs after a certain period of time if that option is enabled. Lastly, but most importantly, it attempts to catch and destroy its target. If it collides with a plane, it will also invoke the plane crash via script. Starting with the missile script, at the top we store a couple of references, settings, and the object state. Under references, we have the rigid body component used to apply physics to the missile, as well as the particle system component used to add some visual flair to the missile. Under settings, we have Stage 1 time, which is the total amount of time the missile will fly upwards to gain altitude. Stage 1 force, the force used to propel the missile upwards. Stage 2 force, the force used to chase the target. Maximum speed, which is the missile's maximum speed. Self-destruct boolean, this denotes whether the missile should self-destruct after a certain period of time. And finally, the self-destruct timer, which is a timer used for self-destruction. Lastly, in our state variables we have the target transform, the fixed update action. This is used to more easily manage state, allows us to just make a single invocation in the fixed update method, rather than having separate state variables and directing behavior with if statements. And finally, the armed boolean notes whether or not the missile is armed and ready to explode. The first method in our missile script is the launch method that for now just wraps the enter stage 1 method. Enter stage 1 does a couple of things. It enables the emission of our smoke particle system, makes the rigid body non-kinematic, and sets the fixed update action to be stage 1. This method is now invoked once per fixed update. In stage 1, we deduct the total time passed since the last frame from the stage 1 time variable. Once it reaches 0 or lower, that means that the missile is entering stage 2. If it is still stage 1, we apply a force to the missile forwards. We applied forwards since the missile is rotated 90 degrees along the x-axis so that the forwards is actually upwards in world space. If the time for stage 1 has expired, we enter stage 2. Armed is set to true, indicating that the missile will explode on collision. Fixed update action is said to be the stage 2 method, which is now invoked on every fixed update. During stage 2, we check if the self-destruct option is enabled. If it is enabled, we reduce the timer. Once it hits 0 or below, we destroy the missile. If the missile should continue chasing the target, we calculate a force to apply to the missile so it follows the target. This is achieved by getting the desired normalized movement direction, which is towards the target's transfer position. Based on that, we calculate the desired velocity vector by multiplying the direction vector by maximum speed. Next, we calculate the acceleration direction. We want our missile to accelerate not towards the target, but towards the desired velocity. Once we have the acceleration direction, we add the force to the missile by multiplying the acceleration direction by stage 2 force. Finally, we rotate the object towards the movement direction. This is not physically accurate, but works well enough in this case. In the destroy missile method, we set the fixed update action to null and destroy the game object. Next, inside of the fixed update method, we invoke the fixed update action if it is not null. Remember, this is either stage 1 or stage 2. And the last thing in our missile script is the onCollision enter method, which checks if the missile should explode on impact and whether or not it collided with a plane. If it did collide with a plane, it causes the plane to go kaboom. The launcher script is used to load and launch missiles. At the top, we have a reference to the missile prefab, a reference to the missile load point, as well as the target transform. Next, we have two input actions to make testing easier. Lastly, under the state variables, we have the current active missile reference. Our first two methods handle setting up and cleaning up our input to allow us to load and launch missiles via keyboard. The load missile method attempts to instantiate a new missile and prepare it for launching. If a missile is already loaded, it simply returns. The launch missile method calls the active missile's launch method if an active missile exists. It then resets the active missile variable to null. The plane script flies the plane, as well as disables flying and turns on gravity, as well as the particle effects when a plane gets hit by a missile. I also used a couple of scripts from an open source package I released called Unitilities. I used the camera-based field of view and the Transform Smooth Look at components. Feel free to check it out, it's free under the MIT license, the link to the repository is in the video description. Now that we have seen our scripts, let's go back to Unity and see how our scene is set up. In Unity, let's start with our launcher. The launcher has the launcher component attached to it. It references the missile prefab, as well as the load point, which is right over here. And it has the enemy plane reference right over here. The enemy plane is a simple object, a simple 3D model with a rigid body which has gravity disabled, a particle system so it emits smoke when it's downed, a box collider so we can collide with something, and the plane script. The plane script references the rigid body and the particle system. The speed is set to 48 and turn speed to 12. Next, back at our launcher, we can take a look at our missile prefab, which is saved under prefabs. It has a rigid body, a box collider, a particle system, and of course the missile component. The rigid body and particle systems are referenced here, and these are the values that I have put right over here. You can see that our target is null because there's currently no target. It's going to be set by the launcher. The last thing I wanted to show you is how I used Unitilities scripts in my project and how I've set up this camera using them. So this camera just follows the plane around and zooms in on it based on distance. I used two components from the Unitilities package, the first one being Transform Smooth Look At. It has the target set to the enemy plane. And I also use the camera distance based field of view, which just zooms in on the enemy plane once it gets far away, and the further it is, the more it zooms in. Thank you very much for watching. I hope you learned something new today. If you have any questions, feel free to leave them in the comments below, and I hope you have a nice day. Bye bye.